Welcome to the second video tutorial for Intro to Dragon. In this video, we will be looking at some of the basic information that is needed when using Dragon, some common syntax that is used, and how to solve simple errors while running Dragon. Dragon runs using an input file that calls on a series of modules available in the Dragon code to perform various calculations related to the neutron transport equation. These modules are distinct but connected structures within the code that each perform a certain task, such as the geo module that is responsible for creating the geometry of the simulation. These input files are known as input decks. First, we will be checking out the documentation that is provided with the Dragon code to help the users. These files can be found in the Guides folder inside the Dragon folder, or they can be downloaded from the Dragon website. The ones we will be looking at today are IGE 163 and IGE 174 R13. In the CLE 2000 toolbox, you can see the coding language that the Dragon code uses. I'm not going to go into too much detail on specifics, but I will direct you to some places where you can find useful information when creating an input deck for Dragon. Section 2 of this document is about the syntax that is used. Syntax are the words and grammar that make up a computer language. In section 2.1, you can see how each type of variable is recognized. Note that strings cannot be longer than 72 characters, and any character past the 72nd column of the input deck will not be considered. Another thing to consider is that there needs to be a space between every entry, meaning there has to be a space before a semicolon to end a statement. Also, any characters following an exclamation point is commented out, and any line starting with an asterisk is a whole comment line. In section 2.2, you can find out how to declare variables. The examples shown here display declaring a variable without defining it, such as in this example here, while other examples show both declaring the variable and initializing it. In section 2.3, you can see how operations and expressions such as logical operators, sine, cosine, absolute values, and so on are handled in CLE 2000. Please note that all arithmetic expressions are handled using the reverse Polish notation. In this notation, the operator follows all of its operands. An example of this would be while trying to add 2 and 5 together, the notation would be 2, 5, then a plus. And say if you were trying to represent this expression here, in reverse Polish notation, it could be either represented as this or this. This may be a bit confusing to get used to for more of the complex mathematical statements, so I recommend doing some review on reverse Polish notation if you're having trouble writing out an equation in Dragon. A good example of how reverse Polish notation is processed can be read here at this site. There is other data available in this document that is not required to know, but may help you succeed at using the Dragon code if you read. Examples of these things are things such as if statements, while loops, repeat and echo statements. Next, we will be looking at the user guide for Dragon. This document contains lots of information about each of the modules, the updates that are made to each version of the Dragon code, and various test case input decks. These test cases are useful references if you're having a very tough time understanding the input format for some of the modules. I recommend reading the first few sections of the user manual as it helps you understand the way the data is presented in this document. In section 2.2, it shows the data structure of an input deck in a very broad sense. It shows all of the structures that can be used outside of a module. Important structures include module, where all of the modules that will be used in this input deck must be declared. Linked list, which creates data structures for the modules to be stored in. XSM file, SEQ binary, and SEQ ASCII, which specifies which type of file a data structure is saved as. This is particularly important as some data must be stored in a particular format for it to be used by later modules in the input deck. After those structures, the modules can start to be called. Section 2.3 goes over all of the modules available in the Dragon code and gives a brief description of their function. There are also section references where you can see what the data structure for each module is. The easiest way to look up a module is by using the Control F function and typing in the name of the module followed by a colon. When using material data in Dragon that is stored in the libraries contained in the WLUP libraries we set up earlier, there is a unique ID number for each material. The data will usually be called upon in the lib module in Dragon. You can find a list of the ID numbers at this website, where it also provides a small description of the materials as well as some of the properties. The last thing we will look at is some runtime errors. If the output file ends with an abort or termination statement, then something went wrong while running the code. For some of the basic errors like misusing syntax, improper data type, or missing or an extra semicolon, by reading the statement just before the termination statement, you can get an idea of what went wrong and the line number that it happened. The best way to diagnose these issues is to go to that line number and see if you can locate these issues yourself. In this first example, we can see at the end of the file, it says there is an error at line 18 with something concerning the geo module. Now by scrolling up, we can see that geo was also declared in the linked list as well as module, which caused this error. To solve this, all that needs to be done is the deleting of the geo. In the second example, it says there was a compiling error. It doesn't say the line number, but by scrolling up, we can see this alert notifying us that there was a misplaced semicolon. Just above where it says this, you will notice that there is no space between the addition and then the semicolon. To fix this, just put a space between the two. In the third example, it says here at the bottom, real data expected. And what caused this is this 3 here at the end. It required a real data variable, which means it needed the decimal point for it to be complete. And finally, in this last example, it says there's something to do with a macro module. This is not an actual module. So by scrolling up, we can see that there was no semicolon to end the module declaration, which made it seem as though macro was intended to be a module. To fix this, just add in the missing semicolon.